Welcome to LR3 lessons 3 and 4. I've put these two lessons together. By the end of these two lessons, you will be able to use triangle shortcuts to prove congruences. Yes, this is two lessons put together, so it is a bit longer. Stick with it. You've got it, guys. All right, let's say we're given that triangle CAT is congruent to triangle DOG. Here's what we know. We know that our corresponding angles are congruent, so angle C is congruent to angle D. Angle A is congruent to angle O. Angle T is congruent to angle G. We also know that our corresponding side lengths are congruent. So CA is congruent to DO. AT is congruent to OG. And CT is congruent to DG. So the converse of this would then be, if we know all of those things, then triangle CAT is congruent to triangle DOG. However, this is a lot to remember. So actually some mathematicians came along and they thought, there might be an easier, quicker way to be able to prove congruent triangles, which is what we're going to look at here. So here are some shortcuts that we're going to use. There are 6 combinations of 3 parts. However, only some of them are going to be valid. And we're going to go through each one. So first, let's look at side, side, side. So we have 3 pairs of congruent sides. So this would be congruent to this. Next, we have side angle side. This is when we have 2 pairs of congruent sides and the included angle, so the angle in between them. Angle side angle would be where we have 2 congruent angles and the included side that are congruent. So something like this, angle and angle, and the side in between. Side angle angle would be 2 pairs of congruent angles and a non-included side that were congruent. So something like this, and then a non-included side. Then we have side side angle, which is where I have 2 congruent sides and an angle that's not included in between them to be congruent. So like this. Finally, we have angle, 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 which is where we have all of the angles showing that they are congruent. Now, these are all the combinations, but not all of them work. And so we're actually going to look at all of them and determine which ones work and which ones are valid. All right, let's first start with side, side, side. And if you click the link to follow the Geogebra, you'll be able to see this through a manipulation. So I highly recommend taking a look at it. And what it shows you is that, let's say we have this triangle. We have these side lengths. What the Geogebra, what it's going to do is it's going to take each of these side lengths and it's going to create another triangle. And the only way to make a triangle using those 3 sides is an identical triangle to the first one. What this means is that side, side, side is a valid shortcut to show 2 triangles are congruent. All right, now let's look at side angle side. So I want you to first start looking at this picture. And again, you can watch the Geogebra. It does a nice job of going through these images and seeing how it actually works in real time. So first we're going to take that side, the included angle, and the other side, and we are going to move it over here to the second triangle. And then the only way to connect this dot and this dot would be with the same length, that same third side. So what this shows is that side angle side is valid. And it proves congruence. Okay, now let's look at angle, angle, angle. So let's say I have this triangle and I have these 3 angles. It is possible for me to basically copy and paste this triangle, not changing the angle measures at all, and we could get a different triangle, one that has different side lengths. Yes, these would be similar triangles, but they would not be congruent triangles. So this one, angle, 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 is not valid to show congruence. Okay, let's take a look now at side, side, side. So again, there's a GeoGebra that shows you this in real time. I would highly encourage you to click on the link and look at how this works in GeoGebra. I'm going to show you through these pictures what it shows on the GeoGebra. So we're going to start with this one. And remember, for side, 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 we have two sides and the non-included angles. So this angle here is going to stay at 30 degrees the whole time. I'm going to show you, we're going to keep B for now at 9, and then we're going to move A. So let's say I make A over here, okay, at 6.3. It can create this triangle using that 6.3, but it can also create this triangle. Those would be the two same side lengths with a non-included angle of 30 degrees. Notice that doesn't change, but I have different triangles that I can create with side, side, side. So what this means is that side, side, side is not valid to show congruent triangles. Okay, now let's look at side angle, angle. So let's say I have this triangle, and I'm going to say I have these two angles that we're working with in this side. Now I know that we looked at angle, 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 and we said that was not valid. However, with side angle, angle, let's remember that if we have two of the angles and then one side, we can then also say that this third angle we can work with, and it would be congruent. What's going to happen now is because I have that side length, it's going to force the rest of the triangle to stay exactly the same. So if I were to look at this triangle, it's going to have to be congruent because that one side is forcing the other two sides to also stay the same because all of our angles are congruent. So right away, even just looking at this, I know that these two triangles are similar because we learned that with angle, angle, angle. We know their side lengths are going to be proportional. But to take it a step further here, because we have one side length and then two angles that are congruent, it forces the other two sides that the only way that we can use those side lengths to create another triangle is if it is a congruent triangle. So side angle, angle is a valid argument to prove that two triangles are congruent. Let me just take a moment to show you one more reasoning behind it. Let's say that this side length was 5 and this side length was 5. We already know because of angle, angle, angle that these two triangles would be similar for sure, which means that if I were to set up the ratio 5 over 5, well, that's not only proportional, that is equal, which means, again, that these two triangles are congruent. Again, proving that this is a valid argument, side angle, angle. Now let's look at angle, side angle. This one is very similar to side angle, angle. So here, in this case, we have two angles and the included side. I'm still able to say that we can use this third angle as well. So what's going to happen here again, just like side angle, angle, is we have two angles, and really now three, with one side given. So it's going to do the same exact thing, which is going to prove that this triangle that is created, the only way to make it with those angles and the one side is if it is congruent, which means that angle, side angle is a valid argument to prove congruence. Okay, now let's take a moment, scroll back up to this slide, and we are going to remember what we just talked about and look at which ones are valid and which ones are not. And let's make a note of it so that when you are working on your practice, you could easily come back to this slide to see which ones work and which ones don't. So let's recall that angle, angle, angle is not valid. Side, side angle is not valid. The rest of them, side, 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 side angle, side, angle, side angle, and side angle, angle are all valid arguments to prove that two triangles are congruent. So these 4 shortcuts work. These 4 shortcuts are valid, and we're going to use those now with some practice. So problem number 1, it says write a congruency statement. When we write these congruency statements, we're seeing we have triangles, we're working with triangles. So we have triangle something is congruent to triangle something by And then it's whatever one of those congruency shortcuts we can use for this particular example. We will use this on every single problem. All right, let's do a little color coding. So I can see that BC and DC match up and are congruent. I can see that AC and EC are congruent. And then we know that these two angles are congruent because they are vertical angles. So here I have two sides in the included angle, which means I have side, angle, side. Let's just remember that the angle does have to go in the middle here. It does have to be side, angle, side because the angle was in between our two sides here. We had the angle between the sides, angle between the sides. Okay, now we're going to list the name of the triangles. So if I want to start with side BC, that was that green side, and then I had CA, that was the red side. When I go to write the second triangle, I have to make sure that I line them up. So B corresponds with D, so it's D. C corresponds with C, so DC. And then we had EC, so we have to put E because E and A correspond. We have to be very careful when we name that second one. When you name the first one, you can choose any order, but then when you go to name the second congruent triangle, you have to make sure that you line up the letters with what corresponds. So if I were to look at this, I know B and D correspond, C and C correspond, A and E correspond. All right, let's take a look at this second example. Remember, we always start with triangle blank is congruent to triangle blank by blank, and we're looking for that shortcut. So again, let's go ahead and highlight. I can see that AB is congruent to CB. I can see that BD is congruent to BD, and this is because it is the same line. Then we are given that these two angles, angle B on angle ABC and then angle CAB or CBD are congruent, which tells me that I have side, the included angle, and another side. So side, angle, side. This can help me then set up my congruency statement. So remember when we look at the first one, we can write it anyway. So I'm going to do A, B, and then D. When I go to set up the next one, I need to make sure I'm doing it in the correct order. So A corresponds with C, B corresponds with B, and then D corresponds with D. Now there is another way that we could write the congruency statement or give the reason, and that's because we have a isosceles triangle, which means that because AB is congruent to CB, remember that that then means that A is congruent, angle A is congruent to angle C. So if we use that information, then it would be angle, side, angle. And let me show you where they are. So we have these angles, we have this side, and then this angle. We have the angle and the included side. Again, the way that we name them would be the same as above. So we could call it ABD is congruent to triangle CBD. Either way would be fine. For this one, it might be easier for you to just trace over it and then use the snipping tool, the scissor tool, to move them off to the side. I am going to redraw them just up here because it's much easier to see when they are a bit separated. Right away looking at this, I can see that OS is congruent to OP, that's given. I can also see they tell me that OM is congruent to OR. And then I can see that they both have angle O right here. So since it's the exact same angle, those of course are going to be congruent. This shows me that I have side, angle, side, and that's the shortcut that we're using to prove that the triangles are congruent. All right, so now we need to name the triangles. When I go to the name of the first one, I can do it however I want. So let's say P-O-R. When I go to the name of the second one, I have to make sure that whatever corresponds with P is written first. So it would be S-O and then M. All right, as I look at this one, I can see that they tell us AB is congruent to ED. I can see that BC is congruent to DC, and then I have angle C and angle C. This is side-side angle. Notice that the angle's not in between, and we learned just earlier that this is not a valid congruent statement. So at this point, we have to say that we cannot determine, so it cannot be determined if these two are congruent. Because hypothetically, if we had more information, they could be congruent. But at this point, with what we're given, we cannot determine that they're congruent. I could also come along with a protractor and figure out, hey, maybe B and D are actually congruent. And then by side angle side, we could say they're congruent. However, I don't know that for sure. So at this point, I can't say that they're congruent and I can't say that they're not. All right, let's look at this example. So I can see that I have A and C that match up and are congruent. I have D and B that match up and are congruent. And then I have the line AC that is congruent to itself because it's the same line in both triangles, which tells me that I have angle, angle, side. So we have angle, angle, side. So now we're ready to name them. I'm going to go D, and then A, and then C. In the other triangle, D corresponds with B, A corresponds with C, and C corresponds with A. Let's look at example number 6, and this one is similar to one that we've already done, and there are actually two ways that we can write this one. So first, let's see that they tell us that DA is congruent to BA. They tell us that this angle is congruent to this angle. We know that AC is congruent to itself. And then because this is an isosceles triangle, we can say that angle D is congruent to angle B. So either we could use side, angle, side, or angle, side, angle. Either one is valid. So if we did side, those red sides are equivalent, and then angle, those angles are congruent, and then side, the green side is congruent to itself. We could do that, and we could write our triangle congruent statement as DAC, which is congruent to BAC. Or I could look and do angle, side, angle. Again, the congruent statement would be the same. DAC is congruent to BAC. All right, example number 7. This would be another one that I would recommend redrawing. It's easier to see. So if you can just copy or trace it, and you'd get triangle DAB and triangle CAB. Bear with me in my drawings. Again, use your tracer tool. It will work much nicer. Okay, so right away I can see that they tell us that angle C and angle D are congruent, and angle B and angle A are congruent. As I look back to the original picture, I can see that AB is the same line in both. So that tells me that AB is congruent to BA. So in this case, I have the congruency statement by angle, angle, side. When we go to set up our triangles, make sure on the first one you can write it however you'd like. So if I want to do D and then B and then A, when I go to write the other one, I need to make sure I'm consistent. So D corresponds to C, B in the first triangle corresponds to A in the second triangle because those two angles are congruent. A in the first triangle corresponds with B in the second triangle. All right, let's take a look at our next example. Here in this picture, I am told that MT is congruent to AK. You can see that using or looking at this dash. That means congruent. And then they are also parallel. These arrows mean that they are parallel. Just because it's parallel doesn't mean it's automatically congruent. Just because it's congruent doesn't mean that it's automatically parallel. You have to be told both of these things. Because MT and AK are parallel, I know that this angle and this angle are going to be congruent. I also know AT is congruent to itself because it's its same line. It has the reflexive property. So if I look at this, I have this side congruent to this side. I have this angle congruent to this angle. And then I have this side congruent to itself. So we can write out our congruency statement. We have M that corresponds to K. We have T that corresponds with A. And then A and T correspond. And our reasoning here is we had side, we had an angle and a side. Also looking at it, we had our two sides and then the angle in between. So side, angle, side is our reasoning. All right, example number 9, we know X, Y, and WZ are parallel because of those arrows. That tells us that. We then can look at this and we can call this line a transversal, which tells us that this angle is congruent to this angle. So W and X are congruent. We can then also look at this line as a transversal, which tells us that Z and Y are congruent. And then we can look and see that we have vertical angles right here. As I look at this, I have 3 congruent angles, but I don't have any congruent sides. So at this point, I do not have enough information to say that they truly are congruent. I know that they're going to be similar, but I don't know for a fact that they are congruent. And somebody could take out a ruler probably and measure and say, oh yeah, these are equal. But I don't have that information right now. So I don't want to say that they're not equal, but I want to say that we cannot determine them to be congruent. So we'll just write cannot be determined. All right, for example number 10, I would start by splitting up these triangles. I would recommend, again, using your trace feature and then moving them. So here we have this triangle. So I'll redraw that up here. And then I will redraw the other triangle. All right, just looking at what they've already given us, they have told us that AD is congruent to AC. They have also told us that angle D and angle C are congruent. We can also say that angle A is congruent to angle A because it's the exact same angle. You can see that in our original picture. It's right there. So in this one, we have a reasoning of angle, side, angle. We have our 2 angles, and then the side is in the middle. So for our triangles, to name them, A and A correspond. D and C correspond, which leaves us with E and B that correspond. It is now time for you to practice. Go ahead and practice, practice, practice. Rewatch any parts of the video that you need. Make sure you have good notes taken. Use that slide with all of the information for all of the shortcuts that you can use that work and the ones that don't work. As always, reach out with any questions.